Or this Sofian, okay. Kersing, you say that you got problem, okay. Yeah, I acknowledge you got problem, but you got to log out from your own personal Google account. Log in under the Neon account as student account. Go and log in. If not, they don't let you go and do the survey. Okay. So
Okay.
let me do the survey, okay, for the surveying the module and the module on soil mechanics, okay. Or you go to the teams, okay, you have access to this the teams PCS, the team, okay. You just need to go and click, right? Need to go and click. Oh, so like for example, my account is already I'm under this one. You can see, okay. Oh, if it's my personal account, it will not be this. Okay, be another one. I cannot go in one. I cannot go in. Okay, I cannot go in. Okay, so I gotta repeat one more. I cannot go in. You gotta go and use your own Neon account. All right. Oh, so can you take some time and go and do that first for those that are all here? Okay, can you go and do? Can or
Okay.
not? The thing can go in now.
Let me try.
Try. You got to log in as your student account, no? Sign in under Google student account.
Yeah, I think, yeah, correct. Yeah. Oh, okay.
Okay, go in or not?
Going already. Yeah.
Is it because of your account problem?
Yes, yes.
Never mind, it's okay. So next time you know what to do. Just go and change it to the student account. It's okay.
Okay, thank you.
Now the next thing to let you know is tomorrow. Tomorrow is a public holiday, so tomorrow I'm not going to do any this Teams session. Okay, I have postponed it. Okay, postpone it to Friday. Okay, I postpone it to Friday. Okay, Friday. Yeah, Friday is 23rd of July. 23rd of July, and we start again as usual at 6:45 on MS Teams. And Friday, I'll be going through the chapter on Pulse, chapter 11. Chapter on Pulse, chapter 11. Okay. And I will also be talking about the test details on this Friday, because there will be a test, okay, that you need to do. Okay. Come to Ngee Ann to do, okay, the test on the 27th of July, which is next Tuesday. Same classroom that you came previously, same timing that you came previously. All right. So please come on this Friday so that at least you know what to go and study. Okay. Any question on this one Friday? Okay or not Friday?
Okay.
Yes, okay.
For those that cannot make it, again, don't worry. Okay, you can always go and download the recording. Okay, that I'll be uh, sharing. Okay, because every session I've recorded down, so you can go and download the recording. Okay, for the Friday one, so that you can understand what are the things to study for the test. Okay, for your soil mechanics and foundation engineering. All right. Now, for today, I'm going to go through again the chapter 6, okay, chapter 6, okay, which is talking about distribution of the this linear misclose using the Bowditch method. I will also talk about the tutorial question 4 from chapter 5, because there is some error that are inside the solution that I have shared with the class. So Mr. Bong here or not? Mr. Bong here or
Yeah.
not? Mr. Bong,
Yes.
so you can look at my solution, okay, when I start to share. In fact, I think the forward bearings, there is also some error, okay. So that's why even if you were to use the forward bearing and then you do the calculation, after you see my numbers, also your number will not be the same as my number, okay. Or you can go and check the forward bearing again, okay. After I can also show you, okay, what are my numbers for the forward bearing, right? Now, let's look at chapter 6 again. Right, so you go to the chapter 6. So chapter 6, they are all together 1, 2, 3, 4. Only four clips very fast. Okay. Or then after we go for a break. Then after that we look at the example that for the chapter 5. Okay.
Let's have a quick recap of chapter 5. So chapter 5, we say that if the surveying work is perfect, then the sum of the latitude will be equal to 0 and the sum of the departure will be equal to 0. However, we'll always be bound to make the measurement error when we are carrying out the traverse survey, and the error can be in terms of error in angle measurement. It can also be in terms of error in linear or distance measurement. So if you have an angular misclose, it means that the sum of the interior angle in your figure, okay, is greater or less than the actual sum of the interior angles. Okay, and you can check whether the error is acceptable or not acceptable. And if it is not acceptable, then you have to redo the survey all over again. Even if it is acceptable, you will still need to distribute the errors to make the angle more accurate before you continue with the rest of the calculations. And you can also have the linear misclose, that means error in distance measurement. Yeah. So again, you can calculate the value of your linear misclose, and from there you can get the relative error of closure. Okay, relative error of closure, and your relative error of closure must be better than 1 in 600, or it must be smaller than 0.00125 in order for your data, surveying data, to be accepted. Even if it's accepted, you will still need to carry out distribution of the linear misclose to make your data even more accurate. And that is the next part that we will be talking about. Okay. Also, we are saying that even if your error can be accepted, okay, the latitudes and the departures should be adjusted so that the sum of the latitude equals to 0, the sum of the departure equals to 0. So the process or the operation of applying correction to the latitudes and the departures of the lines, we call it balancing the traverse. There are two ways to balance the traverse. You can use the Bodish method or you can use the transit method. For this module, we are just going to stick to one method called the Bodish method. So in the Bodish methods, the angles are changed more and the length are changed less. Okay. For the transit method, it's the other way around. We use the Bodish rule to distribute the linear misclose, okay, when the angular as well as the linear measurements are taken with equal precision. By this rule, the total error in latitude and departure is distributed in proportion to the length of the sight. So the formula is this. Correction to the latitude is equals to negative the total error in latitude multiplied by the length of the line divided by the diameter of the traverse. And in the same way, correction to the departure of the line will be equals to negative of the total error in the departure multiplied by the length of the line divided by the diameter of the traverse. Correction can be done graphically, but normally we do it numerically. That means we work out the value. Now this is example 1 in your notes talking about the two coordinates A and B, and given the coordinates you can work out the whole circle bearing, so on and so forth. So that you would have gone through in your chapter 5. So I will leave it as it is and we'll go on to the example 2. So this is example 2. Again, you have a traverse from A to B to C to D back to A, and you have measured the following lines AB, BC, CD, and DA, and you have all these bearings. All bearings are already given to you. So with all this, you are supposed to calculate the coordinates. Okay, and the starting coordinate is station A with northing 0 and easting 0. Okay, northing 0 and easting 0. All right. So once you calculate the coordinates, okay, you can also check what is your relative error, and then after that you can do the balancing, okay, using this Polish method. So let's look at how to do it, and we will start by drawing, okay, drawing the lines AB, BC, CD, and DA because we know the bearing, okay. Right. So if our north is pointing in this direction, then AB, okay, will be probably in this orientation because it's around 344 degrees, okay, 344 degrees, right? Then BC will be in this direction because it's around 88 degrees. CD will be in this direction because it's around 172 degrees. And then after your DA will be in this direction because it's 265 degrees around there, okay? So the lengths are given to you. So for every line starting from AB, you can go and work out what is the latitude, what is the departure. Okay, so let's do that. So by now, I would expect you to know how to calculate the latitude and the departure for all the lines. So for example, AB, I will expect you to get the latitude. Okay, if you know the length, okay, and you know the bearing, you are going to get a latitude of 499.8705. And the departure will be negative 128.9983. So same thing for the line BC. Given the length and the bearing, you should be getting a latitude of 22.2310 and departure of 636.6120. For CD, your latitude should be minus 421.7411. So departure should be 52.531, and then your DA, okay, latitude should be negative 48. This 5186, and your departure should be negative 565.9241. So please go and do the calculation to check whether you are okay with that or not. And normally we will leave it to 3 decimal place, okay, but because we need to do some adjustment, and there will be a need to have a rounding off. So it's perhaps better to leave it to 4 decimal place first, and finally when you finish all your calculation, you can come back to revise it to 3 decimal place. Okay, also just leave it to 4 decimal place. And once you have all these latitude and the departure, you will be able to work out the coordinates of the station B, C, and D because you know the starting coordinates of A, which is 0, 0. Okay, so you can then just take the northing plus the latitude, the easting plus the departure to get the next coordinate, northing plus the latitude, easting plus departure to get the next coordinate, so on and so forth. Okay, so I'll leave it to do that. Okay, and it should look something like this. Okay, so this should be your coordinate. So A should be 0, 0. B, your coordinates, okay, take note, normally we will write the northing first and the easting in the second place, but this one is the reverse order, so just make sure that you are careful about that. So for B, okay, this will be the set of coordinates. C, that will be the set of coordinates. D, that will be the set of coordinates. And you can actually do a calculation of your this point A. And you find that it is not 0, 0. It should be 0, 0, but it is not. So meaning that you started off with point A here, okay, then you go to B, you go to C, and then you go to D. Then by the time you come back to A, you actually miss closing to the point A. Okay, you are a bit of a distance off. And this is the coordinate, calculated coordinate of the point A. So that's why there's some linear misclose. Okay. Alright, so you sum up your latitude, you should be getting a value of 1.838436. You sum up your departure, you should be getting a value of minus 5.7794. Okay, so then you can go and find out what is your linear misclose, which is this one, your linear misclose. Okay, so square root of your latitude plus, square of your latitude plus the square of the departure, then you take the square root. Okay, so you should be getting 6.066 meters. And your relative closing error, okay, will be 6.066 divided by the total distance of your traverse, which is distance AB plus BC plus CB plus BA, which is 2098 meters. Okay, so you go and take the ratio. It will be 1:346. Okay, so 1:346 actually is worse. Okay, worse than 1:600. All right, so in real life, okay, if it is lousier, or worse than 1:600, okay, so that is no good, and you cannot use the data. You have to redo the field exercise to collect the length, okay, and the angles all over again. Okay, but for this exercise, let's continue. Okay, let's just use the value here to do the Bowditch this method to distribute the linear misclose, okay, of so much for the departure and so much for the latitude, so that you get a feel for how to use the formula to do the distribution. So let's start with the line AB. So the line AB, the length is equals to 468 meters. Okay, total length of the traverse is actually 2098. Okay, so the formula for correction to the latitude, okay, will be the error in the latitude. Okay, so in this case, our error for this example, okay, the total error is 1.8436. Okay, right. So there's a minus one sign. So be careful, minus sign in front. Okay, right. So multiplied by the distance of the line divided by the total distance of the traverse. So you will get a value. Okay, so you can round it up to 4 decimal place first. Okay, and use that. Right. So once you have the correction to the latitude, you can then adjust the latitude of the line. Originally, your latitude of the line AB is 449.8705. Okay, that's the original calculation. You will go and add, okay, add your correction. Okay, so this is your adjusted latitude. So you do the same thing for the departure, right? So departure for your AB, now because it's departure, you need to go and get the value of the departure, or you don't use the latitude anymore, use the departure. So the total, departure, okay, summation of your departure is minus 5.7794. So you put it here. Okay. So again, if your departure is a negative value, you just go and put a negative value. Okay. So there's a negative in front. So negative times negative end up you get positive. For this case, positive. Whereas you recall just now, okay, is a negative times positive, you get a negative value. Right. the length of AB is still 458, the total length of the traverse is still 2089. So you go and work out this number, you'll get positive 1.2892083, and you can round it up to just 4 decimal places. Okay. So now your adjusted departure of the line AB will be your original departure, then plus this particular correction. Okay. Plus this particular correction. So this will be your adjusted departure of the line AB. So you can have a table, okay, to put in your adjusted latitude, okay, your adjusted departure, okay, and you continue to build up your table. So now let's look at the line BC. So for the line BC, the length is different. The length is 637, okay. So that's why your correction for the line BC, okay, it will be 637 over the total traverse distance. And your latitude, it will still be the same value, okay, of 1.8436. So you can put it there. So again, you can round it up to 4 decimal places. All right. So you'll be minus 0.5598. And your originally calculated latitude was 22.2310. Okay. So now your adjusted latitude will be 22.2310 plus this correction. Plus this correction. So you get this one, and you can put it into your this table. Okay. So the correction to the departure for the line BC is also in the same way. Okay. You go and find out what is your total departure, summation of the departure, okay, which is this one. Okay. So again, there's a minus sign in front. So minus times your negative number, you get positive number. And the length of BC is actually 637 meters. So you need to put 637 meters here. Okay. Round it up to 4 decimal place. And now you can find out what is your adjusted departure for the line BC. So you take the original departure, then plus your this correction, then this is the adjusted departure. You can then put it here. Let's continue to do the line CD. So again, line CD, the distance is different, is 425 meters. Okay. So the correction to the latitude of the line CD, then you need to use 425 meters, divided by the total length of the traverse. Again, the sum of the latitude is 1.8436, so you put that down here. So you get negative, okay, of this value. Round it up to 4 decimal place, you get negative 0.3735. So then your adjusted latitude of the line CE then becomes negative 421.7411 plus this negative number. Okay, so that's why I get negative 422.1146. You can put that under this particular cell here. And you continue with the correction of the departure for CD. Okay, so departure now, you take the sum of the departure. Okay, so you'll get minus 5.7749, again multiplied by negative sign, okay, then you get the positive number. Alright. So round up to 4 decimal place, so 1.1708. So now you are going to take the original calculated departure, okay, of 52.531 plus the correction. Okay, so we get 53.7018. And then after that, you can continue to do the next line DA. So your line DA, again, the distance is different. It's 568 meters. Okay, so when you are doing the correction for the latitude of the DA, you need to go and use the 568 meters. Other than that, the sum of the latitude still no change with this number here. And you can round it up to 4 decimal places. You'll get the negative 0.4991. Your adjusted latitude of the line DA then becomes the original latitude, then add a negative number. Okay, add negative number, you get minus 49.016. Okay, so for the correction to the departure of the line DA, okay, again, same thing, use the distance 568 meters. Okay, and you can work it out. So you are going to correct 1.5647 meters. Okay, so your adjusted departure of the line DA becomes minus 565.9241, then plus your this correction, you get your minus 4.3594. So once you have your corrected latitude and your corrected departure, okay, you can start to calculate your coordinates all over again, and now your coordinates will be more accurate, okay, more accurate, right? Because you already distributed the linear misclose. So your given coordinate for station A is still northing 0, easting 0. Okay, so this one you don't need to do correction. Okay, coordinate for B now. Okay, just take northing plus latitude. Okay, take note now. This one is the latitude. Okay, latitude. So northing plus the latitude, the easting plus the departure. Okay, so you get this set of coordinate. Okay, that's more accurate compared to the previous calculation for station B. Okay, or station B. Right, then for station C, same thing. You take this northing, okay, northing, okay, plus the latitude, okay, the easting plus the departure, and this is the coordinates of your station C, which is more accurate, okay, more accurate. So do the same thing for your station D. So you do the same thing for your station D. Right, so your station D, again, the northing plus the latitude, the easting plus the departure, so that will be the coordinates for your station D. And then you can do a recalculation to find out the coordinates for your station A. So you take the northing plus the latitude, this easting plus the departure, and if your distribution is done perfectly, you should get back the original value of your given coordinates, which should be 0, 0 in this case. But for our case, we don't get 0, 0, we get actually 0.001, okay, or 1 mm for the northing, 1 mm for the easting. That is because of our rounding off. Okay, that is because of our rounding off. So normally, if the difference is 1 mm, we will accept it's okay. Meaning that we can accept all these coordinates for our surveying and further construction and development works. So this is a summary, okay, of the corrected these coordinates, okay, the northing, okay, and the easting for the station A, B, C, and D. Let's look at the continuation of the example in chapter 5, where we calculated the unadjusted coordinates of the station D, A, and B. So we are going to continue with this example where we use the Polish method to distribute the linear misclose so that the coordinates of the station D, A, and B are more accurate. Okay, so that is to say that while we have filled up this part, okay, we will now carry on to use the Polish method to go and calculate the correction to the latitude and departure for all the lines CD, DA, AB, and BC, and then we can go and calculate the adjusted coordinates. So the correction to the latitude for the first line, okay, yeah, so the first line is CD, so the length of CD is 300.01. Okay, yeah. So this is the sum of the latitudes. Okay, and then this is the total distance of the traverse. So we get the correction. You can leave it to 4 decimal place. Okay, or if you normally it's 4 decimal place or even 3 but the best is 4 decimal place, right? So same thing for the calculation of the correction of the departure. Okay. So now you will be using the sum of the departure. Okay. Also, you can leave it to 4 decimal place if you want. And then after that, you go and find out what is the adjusted latitude. Okay, by taking the calculated latitude plus your correction. Okay. Do the same thing for the adjusted departure. Okay. Calculated the departure plus your correction. So you get the new set of values. Okay. Right. So now your station D, you take the northing plus the latitude. Okay, that means your adjusted one, easting plus the adjusted latitude, and you get the new coordinates. This coordinate will be more accurate. Same thing for the line DA. For the line DA, the distance now is only 300 meters. Okay, so your correction to the latitude will be so much. Your correction to the departure will be so much. Okay, and you can calculate the adjusted latitude and the adjusted departure. So once you have that, then you can calculate the adjusted coordinates of the station A. Again, the northing plus your latitude, the easting plus the departure, and you can get the coordinates. And now you can look at the line AB. For the line AB, the distance is only 276.92 meters. So your correction to the latitude becomes so much. Your correction to the departure, okay, becomes so much. Okay, and you can find out what is your adjusted latitude and your adjusted departure, and therefore you can find the adjusted coordinates of the station B by taking the northing plus the latitude, the easting plus the departure, and you get the adjusted coordinate of station B. Finally, you can find out okay what is the coordinates of station C, okay, by looking at the line BC, which is having a distance of 276.925 meters. So the correction to the latitude becomes negative 0.00864. Correction to the departure becomes negative 0.00144. And the adjusted latitude becomes 178. Adjusted departure becomes 212.134. And finally, your adjusted coordinates of station C comes back to 1299.999 and 1550.001. So it is out by 1 mm, or out by 1 mm, and that is due to the rounding off. That is acceptable. So finally, you can have a table, okay, that looks something like this, okay. So you have your correction and you have adjusted coordinates, and we will use all these adjusted coordinates for our development works, okay. All right. So that will end this chapter on the traverse. So let's look at the line AB. Yeah. So the line AB, the distance is 606.7 meters. Okay. The total distance of the traverse is 3187.98 meters. Okay. So that's why you get 606.7 divided by 3187.98. Now the sum of the latitude is 0.06. You add up all the latitudes, okay, it is 0.06. Okay, so again there's a negative sign, so you get negative 0.011418515. In this case, I'm showing an example where you are correcting to 2 decimal place. Normally, we will correct to at least 3 decimal place or 4 decimal place. 2 decimal place actually is not that accurate. At least 3 or 4 decimal place. But for this example, I just want to show, okay, correcting to 2 decimal place. Okay, right? So that is the latitude. Okay. So you have the correction for the latitude, then you can get your adjusted this latitude. Okay. This one is the unadjusted. Okay, this value plus this value, you get your adjusted latitude to be so much. Okay, then your coordinates, okay, will become 600.04. You just take this starting northing, okay, of this point A, station A, plus the latitude, adjusted latitude of the line AB. Okay, so your this northing becomes 600.04. Okay, right. Then after that, you can do the correction, okay, to the departure for the line AB. Yeah. So for departure, okay, you'll be taking a value of 0.32 because that is the sum of the departures from your traverse. Okay, 0.32. Okay, right. So the line AB is still, the length of the line AB is still the same, 606.7. Okay, so that's why no change to this number here. So end up you're going to get minus 0.0608975. So again, I'm rounding up 2 decimal place because I'm going to show for 2 decimal place. Also, let me repeat again, normally we take it to 3 decimal place or 4 decimal place. 2 is not accurate enough. Okay, alright, so anyway, if we round it up to 2 decimal place, so that is our correction, then our adjusted departure will be the original departure plus this value here. Okay, so negative value plus another negative value, so we get minus 599.75. Okay, so therefore the coordinates, okay, will become the easting plus the departure, so we get 500.25. Okay, So this becomes the coordinates of our station P. Then we go on to do the adjustment for the line BC. So for the line BC, the distance is actually 471.7 meters. So we need to change that to 471.7 meters. The total length of traverse no change. Okay, and if you are doing correction to the latitude, you need to take the sum of the latitude. Sum of the latitude. So that's why you get 0.06. So you get the negative 0.008877721. Again, I round up to one decimal place. I get the negative 0.01. Right? So my number for correction is 0.01. Okay, and my this adjusted latitude finally becomes 249.99. Okay, and my northing, okay, for my station C therefore becomes the northing plus this the latitude. Okay, also I get 850.03. Okay, so let's go on to look at the correction of the departure for the line BC. Right, so for the line BC, again, you use back the length of the line BC, which is 471.7, okay, but now you're doing the departure, so you need to use 0.32. Sum of the departure is 0.32, so you put 0.32 here. So end up, you have negative 0.04734785. Again, rounding up to two decimal places, I get minus 0.05. So that is my correction to the departure for the line BC. And therefore, my adjusted departure, okay, will be minus 400 plus negative 0.05. Okay, so that's why I get minus 400.05. And therefore, my easting, okay, for my station C will be the easting plus the departure. Okay, so I get 100.2. And then you go on to the line CD. Right, so the line CD, the distance is 751.65 meters. Okay, so your correction to the latitude end up you're going to get minus 0.0141465575. Again, I round it up to one decimal place. So my correction for the latitude to the line CD, I'm using negative 0.01. So my adjusted latitude, okay, therefore become minus 750.0. Okay, and my this coordinate, okay, the northing, okay, for my station D then becomes the northing plus the the latitude. Okay, so I get the 100.03. Yeah, so let's look at the correction to the departure for the line CD. So the correction to the departure for line CD will be minus 0.075440403. So I'm rounding up to 0.07 negative, negative 0.07. So I put it here. So therefore, my adjusted departure, okay, becomes 49.93, and my easting for the station D finally becomes 150.13. Okay. So for the line DE, okay, for the line DE, okay, my distance is 855.87, okay, 855.87, right? So therefore, my correction to the latitude becomes so much, okay, so minus 0.02, like that, yeah. So then the final, this adjusted latitude becomes 99.98, okay, and my this latitude, okay, for the station E, okay, is 200.01. Okay, so my correction to the departure for the line DE, okay, I'm using minus 0.09, yeah, and therefore I get the easting for my station E to be 1000.05. Okay, so this is my correction to the departure for the station A. Okay, yeah. Also, I get this. So this is my correction to the latitude for the the line DA. Right. Yeah.
Okay. Also now, let's go for a break. Okay, let's come back to talk about this question. Okay, are we all back ready? Right. Now, let me just open up the file. Okay. All right, let's look at the question. Also, this is the question, right? This one is found in the chapter 5, the tutorial question. So if you were to go to chapter 5, and you look at the tutorial question, okay, the tutorial question, right? You should be able to find this particular question, okay? Also, can everybody find the question? Is it okay? We're going to go through this question step by step. Yeah. Is it okay? No response, so I don't know whether to wait or to not wait. So I need some response. Only Mr. Bong is with me only. The rest all not with me. How about the rest? Kersing, thank you. Yeah, I can see your light flashing out. Yeah. So only Mr. Bong and Kersing only. Mr. Bong and Kersing only, is it? Okay lah, never mind. Since only two, yeah, I don't mind. It's okay. Yeah. Also, this Kersing, you can find the tutorial question or not?
Sorry, no, I'm driving.
Oh, you're driving. You're driving. Then go and drive carefully.
Later.
Drive carefully. Don't be distracted. So I think only Mr. Bong only. Okay, never mind. Then just Mr. Bong. All right. Okay, so obviously, Mr. Bong, you have this question, So yeah, you go through the procedure as per what is shown in the example. So there is a traverse, okay, from A to B to C to D back to A, yeah. And the information that was collected in the traverse are the interior angles, angle A, B, C, and D. Okay, all these are all the measured angles. The distance are also measured, okay, or AB, BC, CD, and then the DA. Okay, all these are all the measured distances, right? So the question asks you to compute the unadjusted coordinate. So that means you don't need to use the Brodage method, right? So first thing you need to do is to go and add up the angles to see whether you get the 360 degrees. Yeah. So Oh, so from here, okay, if you were to add up the angles, okay, you find that it is not 360 degrees. Oh, in fact, it is 360 degrees and there is 20 seconds, right? 20 seconds, okay. Oh, so any problem with doing this?
Okay, no problem.
No problem, right?
Well,
So no problem. So now can you suggest to me what to do next after you have done this step?
Okay, then find the allowable misclose.
Find the allowable misclose. Okay, very good. Okay, how to find the allowable misclose?
Plus minus 1.4 divided by the total angle.
Plus minus
One
one, square root of
square
square
root
root of
of one
4.
square root for 4.
Plus minus square of 4.
Hmm.
So plus square of 4 is 2 lah,
Yes,
right?
the answer is 0.5 lah.
Answer 0.5. $0.5.
0.5 degrees.
0.5 degrees. So 0.5 degrees is 30 minutes lah. So plus minus 30 minutes. Okay, plus minus 30 minutes. So that is the allowable range. So as long as your error, angular misclose, is within plus minus 30 minutes, you will accept lah. Okay. So now you can compare 20 seconds. Okay, is it within the range?
Yes.
Yes, so then you can accept. Okay. So yes, okay, so you done that, then you accept. So after you accept already, what do you do next?
Then distribute the angular misclose equally to 4 angle.
Okay, all right. Do you know why you want to distribute equally to 4 angles?
Then so the everything add up become 360 lah.
Yeah, okay. So that your measurement become more accurate, because your measurement there's error, you see. Or there's an error. So that's why you have 20 seconds extra. So what you want to do is you want to make your measurement become more accurate, and you're assuming that the error that you make is the same error that you have committed for angle A, for angle B, for angle C, for angle D. It is the same type of error. So that's why it's divided by 4. If let's say in practice there is reason for you to believe that there is not much error for A, B, and C, but for D you make quite a lot of error, you can actually put inside your calculation that you want to attribute all the error to angle D. Then you will not be divided by 4 already lah. So you just go and take the angle D plus the error, which is 20 seconds. You get what I'm trying to say?
Okay, can understand.
So it depends on what is your basis for deciding where the error comes from. If let's say really you do the field work and you think through and then you really cannot find any reason, any station there's a major error, normally you will attribute the error to be equal, okay, throughout your whole field work. Okay, so that's normally what we do. So we got 4 angle, we divide by 4. So that means every angle we will go and add. Okay, we add this error, which is minus 5 seconds. So minus 5 seconds is because minus 20 divided by 4, right? Correct or not?
Yes.
So then the adjusted error, okay, the adjusted error therefore become minus 5 seconds, right? Minus 5 seconds. So wait, you add the thing. Wait, 59, 29, 25. Original is what? 59. Oh, it's here. Okay. This angle B. Okay, 25. Okay. All right. So this one is actually angle B. Okay. 59, 29, 25. Let me see. 59, 29, 25. This is B.
B
Okay.
is 13613.
Yeah. Okay. B.
136 degree, 13 minutes 6 seconds.
Wait. This angle B, because you see, here I put down my angle B is 59, 29, 30. Can you see?
Yeah.
This is my angle B. So when I go and do the adjustment for angle B, I will add negative 5 seconds. So you'll be 59, 29, 25 lah. So that means this one is actually B.
B?
B. This is B.
The angle B should be 136 something, right? Ah,
Are you referring to from here or
yeah,
this one?
right.
Oh, okay, wait. Okay, this is A. Okay, so that means A is this. So that means here, that means A is not correct lah. This is A. What, how to say? Let me come back to here again. One at a time. A is 59, 29, 30. Fine. 59, 29, 30. So that means this one should be A. So I change it so that easier for people to follow. And after that, okay, 52, that one, 52.
This one is C.
C, okay lah, C lah. C,
112 is D.
now is B lah. Okay. Oh, correct, right? Okay. So now coming back, okay. So B is okay. Let me just do a check. A is 59. A 59, okay. B is 136. Then C is 52. D is 112. Okay, so all okay already. Alright. So after you have go and distributed the angles, okay, then the answer, okay, should give you back the 60 lah. Okay. So far okay, right? So far.
Yes.
Okay, then after you need to use the bearing okay, of the one line, okay, they give to you the line is AB, okay, AB is 326, then 1837, okay. So from there, okay, you try to work out the rest of the bearing of the rest of the lines, okay. So that part, let me just go and get a calculator. Give me a minute. Okay, calculator is not here. Okay, so I don't have a calculator with me, so you have to go and do the calculation for me. So Mr. Pong just go through the calculation for me. Okay, so let's do line by line. The first line, okay, AB is 362, 1837. This one okay, right? Oh.
Okay.
So then the backward bearing will be this angle subtract away 180 degrees. So it'll be 146, 1837. This one okay, not okay?
Wait, I see.
You just take 362, 326 minus 180.
326,
Uh,
18, 37
minus
minus
180.
146, 18, 37. Okay.
Yeah, okay. So now the angle is angle A. So angle A, okay, you look back at your adjusted one, adjusted angle A is 59, 29, 25. Okay, so you're going to use this. Okay. So your forward bearing for the next line, okay, for this BC, okay, will be equals to this angle subtract away the angle A, 59, 29, 25. So you subtract, what value do you get?
No. Wait, what subset what?
Yeah, you look at it, you can look at this one for example.
Ah.
Okay. The angle A, okay, is equals to 59. You can see here 59 degrees, 29 minutes and 25 seconds, right? The angle A.
Ah.
Oh, okay. Let me just look at the diagram. So now you're trying to get the angle. Oh, sorry, you should be subtracting the angle B. Angle B. Okay. Angle B is 136 degrees, 13 minutes and 11 seconds.
6
Okay.
seconds.
Sorry.
This one is one angle B.
Mm.
11 second is before adjusted, ma. We have to go for the adjusted, right?
Correct.
6.
You are right. Use this one. 136, 13 and 6.
6.
Yeah. So use
Okay.
this one.
Ah.
Oh. So that means you use your 146, 18, 37, subtract away the yeah, this one. Okay. 113, 136, 13, 6.
Okay.
So you get, what do you get?
10, 5, 31.
31, huh? Okay, so
26 should be 31 lah.
sorry, who is talking?
Turn lane.
Sorry. Sorry again, who is talking?
Turn lane, Mr.
Oh,
Teo.
Sunday, huh? Okay, Sunday, huh? Okay, double check. Okay, two of you all double check for me. All right? Oh, so you should be getting 10, 5, and 31. Okay, no, okay?
Yeah.
Yeah.
Okay, huh? Then you continue to the next line, okay? By trying to find the backward bearing of the line BC first. Forward bearing of the line BC you found already. 10, 5, 31. Okay. Backward bearing of the line BC you want to find, you will add 180 degrees.
Okay. 190 degree, 5 minutes, 31 seconds.
So also 26 change to 31 lah.
Yes, correct. Also, let's do that. Okay. Once you have found the backward bearing of the line BC, or you can then look at the adjusted angle C, the adjusted angle C. Okay, adjusted angle C. So your adjusted angle C is 52, 16, and 12. Okay, 52, 16, and 12. So you take your backward bearing, okay, 190, 531 minus the 52, 16, and 12. Okay, and what do you get?
So the 9 change to 19.
So this one is 19.
Yes.
Then after that, you look at the line for the next line. Okay, as usual, you go and find the backward bearing of the line CD first. Okay. Also, now you take your forward bearing plus 180 degrees. Okay. So, am I correct to say that it will be 317, 49, 19?
Yeah.
Yes.
All right. Then, what you need to do is to go and find again the forward bearing, okay, of the line DA lah, okay, or forward bearing of the line DA. Yeah. So now, if you want to find forward bearing of the line DA, you look at the angle D, okay, adjusted angle D. So your adjusted angle D is 112, 117, right? So you take your this 317, 49, 19, subtract away the 112, 117. So what answer do you get?
2548. 47 change to 48. Then
205, 48, then
2 seconds.
205, 48, 47.
2.
This one is 02.
Yeah, 02.
right? Oh, now this one is just I'm doing my own check, okay? Oh, you don't need to do the check if you don't want to, but I just want to do a check just to make sure that I'm getting the angle correct, okay? Oh, so let's just don't do the check because you don't need that for your calculation, okay? So let's just take that out. Okay. So once you have the fault bearing for all your lines, okay, you can go ahead to calculate the latitude and the departure for all the lines. Starting with the line AB, okay. So starting with the line AB, okay, the distance of line AB is 721.14, and the coordinate is N100 and E1400 lah. Also, this is what you have been given. So the fault bearing of the line AB is 326, 18, 37. So you go and take this angle, cosine of this angle multiplied by the distance of the line, that will give the latitude. So can you check the latitude? Do you get the 600.027? Is that okay? I think Mr. Bong, you get the number, right?
Yes.
How about Chen Lei?
Sorry, Mr. Teo, the calculator not in my hand. Let me find.
Yeah, I also trying to find my calculator. I left it in school, so I don't have a calculator with me. Okay, so and we can continue. Okay, also for Mr. Bong, okay, the departure of the line minus 400.013, you're okay or not?
Okay.
So if that's the case, then the coordinate of B will be this value 700.027 and 999.987. So this one, you're okay with it?
Yes.
Okay, so far so good, up to here.
Yeah.
Okay, that's good. That's good. Then you continue to the next line. Okay, continue the next line. So for the line BC, okay, you use the bearing, okay, line BC, use the bearing of 10, 5, and 31. Okay, so meaning that the cosine of 10 degrees, 5 minutes, and 31 seconds multiplied by the distance of 921.96. Okay, so that will give you the latitude. So what will be the latitude if you were to do the calculation? What is the latitude? Can you let me know?
5, 21. 907.695.
Wait, 907.615.
No, 907.695.
Okay lah. So I take that lah. It's okay. Also 907.615. Okay.
69699. Okay, 90695, correct.
Then your easting, this is the departure.
The departure, I counter check.
161.553.
Sorry, one come again.
161.553.
161.553,
Mm.
Yes. Okay. And who is that?
Rockable, sir.
Okay. All right, Rocky Boo. Hey, by the way, Rocky Boo, have you done the module evaluation?
No, sir, I haven't, sir.
I haven't. Hey, I show you. Wait. Sorry, we take a break first. Okay. You go to the team, the meeting. Okay. Or you will be able to see two URL. This one is the module evaluation for the surveying. Then the other one is the module evaluation for the soil mechanics. Okay.
Okay, sir.
When you do this, you got to come out from your Google, your individual, your own what call it username. You got to use your student ID, student password to go into the Google.
Okay, sir.
All right. Can you try that? Try that now. I wait for you. Make sure that you can go in first.
Right.
You can go in
I
already.
tried it, sir.
Huh?
Sir, I can go in, sir.
You can go in. Okay, you can go in. Don't do now. Never mind. Okay, we continue. We can continue. Okay. Oh, and then by the way, this Chen Lei and this Mr. Bong. Okay. Can you all access to do the survey?
Yeah.
Now
Okay,
ready.
now. Don't do now. As long as I know you can access, it's okay. Okay. All right. Never mind. Okay. Let's come back. Let's come back. Okay. Oh. So everybody okay with these two set of latitude and departure? Is it okay? This one.
Yes, sir.
How about Mr. Bong?
19155. Yeah. Okay.
Okay. Then you can go and calculate the coordinate of the point C already. So what you do is that you just take the northing plus the latitude, the easting plus the departure. So give me the new coordinate of point C, please.
North 1607.722.
And
Easting
how about east?
1161.540.
So how this Rocky Boo, are you able
Yes,
to
sir.
get that?
Yes, sir.
Okay.
Correct. Yes.
Very good. Okay. Then you can go on to the next line, okay, the line CD lah, right? So the line CD again, you look at the line CD, the ball bearing is 137.4919. So you take cosine of 137.4919 multiplied by the length of CD, that will give you the latitude. You take sine of 137 degrees 49 minutes and 19 seconds multiplied by the distance, that will give you the departure of the line CD, right? So if you were to do that, okay, tell me what value you are getting. What is the latitude and what is the departure?
Minus 696.161.
Minus 696.161 meter. That is your latitude. How about departure?
Departure is 630.754.
630.754.
Yeah.
Okay or not, Mr. Wong?
Okay, can.
Then you can find out the coordinate of the point C, okay, and let me know.
Nine double 1.561.
Sorry, come again.
911.561.
Easting.
1792.294.
1792.294. Oh, Mr. Bong, okay with the number here? This one?
Okay, can.
Okay, let me just screen capture this one. Okay. All right. And I save it. Okay. Let me just go to here to see whether check. Okay, good. Okay. So that completes the example. Okay. So we solve out the typo error. Thank you for sharing that with me. Okay. Any other question you all want to ask in general about the chapter 4, 5, and 6, which is talking about the horizontal control the latitude at the departure, the easting, and the northing. Yeah. Any question?
Okay, the question just now the question 4 we still need to do the linear miscross traverse distance to counter check the crossing area or not?
Yes, yes, yes. If you are doing a project, okay, you will need to go and continue, okay, or continue to from here, all right, or you will need to go and get your go back, do one more set, okay, to get the coordinate of A, okay, and you find that your coordinate of A is not exactly equals to N100 E 1400. Okay,
Yes.
it will be different, okay, because of the linear error. Then you will have every line, A, B, B, C, C, D, and D, A. Every line you will have latitude, 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 latitude. You add up all the latitude first, okay? Every line, okay, will have departure. So you have 1 departure, 2 departure, 3 departure, and 4 departure. You add up all the 4 departures, okay? Then after that, you go and use the Pythagoras theorem, okay? Latitude square plus departure square add up together, square root, okay? That will give you the linear misclose, all right? Or then you check for the accuracy of your traverse. You take your linear misclose, divide by the total distance of AB to base C to CD to DA. So that must be better than 1 in 600 lah, right? Or so once you clear that, then you do the voltage distribution to go and distribute. Yeah. Is that okay?
Okay.
Any question from any of the students that are around? Justin, you just came in, Justin. Justin? Justin? No around. So only Mr. Bong, this Rocky Boo, and Chen Lei. Kersing is driving the car, no, so now not around anymore.
Reach home already.
Reach home already. Kersing, reach home already.
Yes,
never...
yes.
Oh, you're here. Okay. Oh, so if you missed just now what I've gone through, Kersing, you don't worry, you can look at the recording. Okay, the recording will be up probably around after 10 o'clock already lah. Oh, so you can look at it tomorrow also if you want, or some other day. There's a recording lah. We go through the example. Okay, there's a few typo errors, so the numbers are not correct.
Okay.
There will be a test for this module, the surveying also. The test is on the 5th of August. Okay, 5th of August. And the test will be on this chapter 4, 5, and 6. 4, 5, and 6. I think it's best not to have it as an open book test, because open book, okay, the auditor will require a higher, tougher test question. So if you understand the procedure, okay, the procedure is very straightforward, meaning that regardless of how many points you have, how many data you have, okay, the procedure always is that, okay, number one, okay, if it is a polygon, your test question will be a polygon. If it's a polygon, okay, go and add up the interior angles. Go and add up, because you measure the interior angles of your polygon. Go and add it up, okay? Add it up, okay, so that you can find the angular misclose. Angular misclose is always the true value minus your measured value. So if it's a 3-sided figure, the true value must be 180 degrees. 4-sided figure, 360 degrees. 5-sided figure, 540. Okay, we will not go beyond that, but in theory, 6-sided, 7-sided, 8-sided is the same. Okay, in theory, right? So you find your angular misclose first. After you have found the angular misclose already, okay, you go and find out what is the maximum allowable angular misclose. So it's a range plus minus, right? So you go and use the formula square root of 1/4 times square of n. N refers to the number of sides in your polygon. 3 side, 4 side, 5 side. The n will be 3 or 4 or 5. So if you use that formula, okay, the unit will be in terms of degrees. So you auto convert yourself to minutes and seconds. So make sure that your angular misclose is within the range. Right? If your angular misclose is out of the range, okay, in actual life, your project, you will need to redo. Okay, but if it's within, okay, you don't need to redo, but you still need to distribute your angular misclose. All right. So just now I discussed with Mr. Bong. Okay, normally we assume that the error is equal. Okay. Also, you divide by the number of angles that you have, then you go and distribute. So you get a more accurate interior angle. We call it adjusted. Okay, because you already distribute, so that's why I call it adjusted. So you make use of the adjusted angles for you to find the forward bearing of all the lines. Okay, all the lines. You must have a bearing of a starting line first. Okay, if you don't have a bearing of a starting line, there's nothing to talk about. Okay, so you always need to know, okay, your starting line, what is the bearing. Once you know your starting line, what is the bearing already, typically you go and take the backward bearing of your starting line, okay, subtract away this adjusted interior angle. That will allow you to find the forward bearing of the next line. Then you go and use the same process. Okay. So you continue to use the same process. Okay. That will allow you to find the forward bearing of the rest of the lines. Okay, you need the forward bearing of all the lines, because only when you have the forward bearing of all the lines, then you can find for every line what is the latitude, what is the departure. Okay, if you do not know the latitude and the departure of the line, then you cannot calculate, or you cannot go and work out the coordinates, okay, of the rest of the point. Okay, also that's why you always need the forward bearing of the rest of the lines. So you start with your starting line. Your starting line, the starting point, your control point, you must know the northing and easting. That's why it's called control point. You know the northing and easting. Then the line, okay, that you start out with, you know the bearing, you go and calculate the latitude, the departure. Then the northing plus latitude, easting plus departure, that will give you the coordinate of the next, the other point in your line. Then you continue and continue and continue. Okay. So you do that one round, at least you get the unadjusted coordinates. Okay. Why is it unadjusted? Because you may be thinking you already adjust for the angular misclose. How come it's unadjusted? The reason is because you have not adjusted for the linear misclose. So that's why you need to do the adjustment for the linear misclose first before your coordinates are adjusted. That's the reason. Right? So for doing this adjustment for the linear misclose, that you will need to use the Bowditch distribution method. Okay. Because I only go through you one method, the Bowditch distribution method. I didn't go through the transit method. Okay. Transit method, the formula is a bit different. Okay. Also, actually, there's a choice. You can use Bowditch or transit. Right. So if you want to do the adjustment using the Bowditch method, you need to find out the sum of the latitudes of all your lines, the sum of departures of all your lines first. Okay. So that's why it helps if you have a table and you put in the number systematically. Because when you put the number systematically in a table form, easy for you to go and add, okay, the values. All right. So that's why use the table, or the best is you use Excel, for example. Okay. All right. So you need to sum up the latitude, sum up the departure, then you can find your linear misclose, which is the square root of the latitude square plus the departure square. Okay. So once you found your linear misclose already, okay, you need to find the accuracy of your traverse, which is to say that you take the linear misclose, divide by the total distance of your traverse. Okay, the total distance of traverse. Then you have a ratio. You can have it as a decimal number, it's okay. Okay, but the decimal number, sometimes people find it very difficult to compare. So normally we compare as a form of ratio, you compare versus 1 over 600. So it must be better than 1 in 600. Better than 1 in 600, that means your number must be 1 in 700, for example, 1 in 800, 1 in 1000, 1 in 601. Anything more than 600 is good. Okay. So when you use a calculator give you a decimal number. If you want to see what is the ratio, okay, 1 over something, you go and press, okay, your calculator button, okay, x to the power of -1, that one. Okay, that is called the reciprocal. You go and press that, okay, then you can get the number and you can compare against 600. It must be better than 600. All right. So if it's better than 600, okay, then you can use your data. If it's lousier than 600, 1 in 500, 1 in 400, 1 in 300, you have to redo your fieldwork again. No choice. Okay. Also better than 1 in 600, okay, you then continue with your this data processing. Now you can use the Polish method to go and make your resulting coordinates more accurate. So the Polish method, there is a formula lah, okay, is negative of the sum of your latitude multiplied by the line that you want to do the adjustment divided by the total parameter of your traverse. Okay, then negative of the sum of the departure multiplied by the line divided by the parameter of your total traverse. So you have two numbers, okay, for you to adjust to the latitude and the departure of that particular line. Okay, so once you adjusted the latitude and departure of that particular line, okay, you can find out the coordinate of the next point along the line, and then you continue on and on and on. So that is the procedure, if I sum it up, okay, in verbal form. Okay. Any question? Okay, no question. I would like the rest to use the time to do the survey. For those that already done the survey, then you can go off, okay, for today. All right. So let me just put it down. So remember to come, okay, on Friday, on MS Teams, okay, where I'll talk about the calculation, chapter on pulse, okay, for the soil mechanics and foundation engineering. Okay. So let me just okay, so for those that already done the survey, okay, thank you. Okay, and that's all for today. Okay, I see you on Friday. Okay, there will be some that will be coming this Thursday for the hands-on, the practical at the Ngee campus. Okay, I will separate message to you guys. Okay, but the whole class, okay, the next lesson will be Friday, not tomorrow, because tomorrow is a public holiday. Yeah. For those that have not done the survey, okay, you can see here, okay, this is example, okay, oh, so there's one on the soil, this surveying, okay, then below is the link, okay, for the this soil mechanics and foundation engineering, but you have to use your student account, okay, you cannot use your own personal account, you can't get in, okay, you have to use your student account, right? Please go and try, go and try. Thank you, okay. Any question that you know, any things that you may have a problem with, WhatsApp to me, okay, or WhatsApp to me, okay. Oh, thank you for those that are here. Okay, thank you.
Thank you. Thank you.